Welcome back, AP. Welcome back to it. Welcome back to your flipped classroom and our continuing discussion of the rise of the scientific revolution in the 16th, 17th century, that whole time period. So the biggest thing about it, though, is we left off in class talking about the rise of this period of time known as what some historians refer to as the Age of Genius, right? The Age of Genius, of course, referring to the scientific revolution that occurred starting in the mid-1500s, going all the way into the 16 and 1700s, and then as well as the Enlightenment that will catapult off the back end of the scientific revolution, leading us later on into things like revolutions and massive church reform and blah, 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 blah. It's very important stuff. And it's also a period of time that I really enjoy teaching. Not the Enlightenment so much, but the scientific revolution I really, really enjoy. And we left off in class talking about Copernicus, right? Not Copernicus, okay? His name is Nicholas Copernicus, all right? Now, Copernicus is a Polish scientist who is going to start this whole scientific revolutionary wave. Now, something that we need to kind of have a disclaimer about before we start talking about him, like a disclaimer that we need before we start talking about him, besides the fact that he looks like Lord Farquaad from Shrek, is a big thing about the idea that he's going to come up with, right? So the big thing that he's going to postulate, that he's going to put out there, that he's going to write an entire book about trying to prove. A lot of people will tell you he's the very first guy to come up with it, and that's actually not true, right? Like ancient scientists like Samos of Thrace theorized this, right? You've got some people that were contemporaries of Aristotle that theorized his idea as well, and then as well as another Frenchman named Nicolas Oraim actually came up with the same theory as well, right around the same time period. So just know that going into this, that like these scientists that we do talk about, it's much more about the trends that they started and their big key fact, rather than being the first, second, third, or wherever in line. All right, or basically the idea that they're giving credit for a monumental discovery. Now, Nicholas Copernicus' biggest thing is he's going to be the very first one to create a new model of the universe that will go in contrast to Aristotle and the contemporary at the time in the 1500s Ptolemaic model, right? The Ptolemaic model, which was the the geocentric one that had the Earth in the middle and the planets circling around it in a spherical style pattern. Nicholas Copernicus is going to be the very first one to publish a book that proposes the heliocentric model, right? And he does so in a book that is very, very important, all right? The book you need to know, the book you must write down, the book that he's going to publish in 1543 is going to be known as De Revolutione Celestio Orbinum, or also known as the Revolutions of the Heavenly Spheres, right? Now, for those of you who just paused this and then rewound it and wrote it 18 times and had the entire title of the book, you messed up. You done gone and messed up, right? And the reason why is that because that most academics, most college professors, most people in academic circles just shorten it down to, and they refer to it as simply De Rev, right? And what it means basically in the title in Latin is just like how the heavenly spheres move around, right? Like the revolutions of the heavenly spheres. Now, the interesting thing about it, though, is this book, however long and however full of kind of weird, odd math that was in it, and then also the fact that he believed that there were like these crystalline things around the planets and stuff, the biggest key thing about the book that he writes, again, De Rev, the book that he writes, is that one, he's going to die days later, right? Like right after he publishes this book, he dies. Now, this could have been because he was fearing like persecution from the church, or it just could have been like, he was sick and in bad timing. Now, but the other thing about it is, regardless of how long the book was and however many other inaccuracies were inside of it, the thing that we need to remember is that he is going to propose the heliocentric model, and in conjunction with the printing press, it's going to spread like wildfire, right? And people are going to begin to gravitate towards this, not pick it up immediately. It doesn't actually get condoned or really, really accepted until about 100 years later, but still, he's making a wave, right? Something that we need to understand about the scientific revolution is that even though people are not going to immediately go towards a new idea, doesn't mean that that wave still hasn't been made, that ripple in the pond is still not spreading across the entire surface of the water, right? So when he publishes this book and then dies, the thing that's going to be very interesting is you're going to see a lot of experts, quote unquote, reject his theory due to one major reason, right? And the reason why they reject it is, one, most of them are church authorities, and they don't like the fact that he's proposing something that goes against the Catholic Church at the time. And two, the other reason why is because Nicholas Copernicus's book did not compensate for a fictional, not real movement in the universe. Later on in life, you're going to meet people, all right? You're going to meet people that believe in this shenanigans called retrograde motion, okay? Quote unquote. like my wife, for example, who believes in retrograde motion and how
Are you done yet?
and how the movement of the planets going backwards makes you feel some type of way.
But the planets don't actually move backward at all.
Now, the biggest thing you need to understand is that, anyway, retrograde motion, not real. All right? Like, not a real thing. It is an observational phenomenon. But the problem is, though, is if you're using your naked eye to observe the stars, it does appear as though some of the planets are going backwards, right? And again, they're not, all right? So, but it appears as though some of them are going backwards, right? The reason why has to do with the position of the Earth in comparison to other planets at the given time of observation, right? So if you're looking at this graph right here, if you look at Mars from this position on our orbit, it looks like it's out here in the sky due to it being projected out into space, right? And then if you look at it here when it's lined up, it's right there, da-da-da. And so it looks like it's moving backwards, but it's not, all right? So like, and it's just an observational phenomenon. But these experts are going to be like, no, Copernicus' idea can't make any sense because we can't start journeys or we're going to feel funny. And then also because like the planets move backwards. And they don't, all right? Like, so like they actually do not do that. So if anybody sells you on this retrograde motion shenanigans, just tell them it's not real. All right? Like now, so going into it though as well, something that you also need to know is the Copernican model will live on though, regardless of it being rejected and regardless of the experts saying it's not going to work because of the retrograde motion issue and stuff like that, and regardless of the fact it's going to take 100 years for it really to grab on, doesn't mean that it won't still be a very important thing that scientists continue to study, right? Because also, you have to understand, a scientific revolution can still keep churning forward if people are trying to study the night sky to prove that he was wrong, right? Do you see what I'm saying right there? Just because his idea didn't catch on and become accepted for 100 years doesn't mean it's not still very important, all right? The Copernican model will live on, and also it will begin to gain steam, so much steam that by 1616, his book will be added to the Index of Banned Books by the Catholic Church, right? The same book list that Pope Paul III started with the Catholic Counter-Reformation. Y'all remember the Counter-Reformation, right? We are living all up in some Counter-Reformation era Catholic Church, right? This entire era that we're going to be dealing with is really focused in on the church trying to prevent other followers from leaving, right? Like, so now, because this is all happening during the Reformation, right? Like, we see that year, 1543, when he published his De Rev, that's like 30 years almost into the Reformation after Martin Luther, right? Now that Copernicus is dead, though, and now that his book has made some waves, we're now going to move on to another guy who is a Danish scientist, right? He's a little bit of a party boy, and his name is Tycho Brahe, right? Or Tycho Brahe, when you refer to him. The reason why I call him a party boy is because legit, he was, right? My guy loved to have, like, celebrations, loved to do them in his massive mansion on an island that was given to him by the Danish king, right? So the thing that was really interesting about Tycho Brahe was his personality. He's a very weird guy, right? Funny guy in the sense where he loved to throw down, loved to have a good time, but he also was super obsessed with studying the stars, right? So now, interesting thing about it, though, is he was such a good astronomer, right, that the Danish king at the time actually gifted Tycho an island to prevent him from leaving Denmark, right? He didn't want him to leave because if Tycho comes up with an amazing discovery, the king basically wants to benefit off of it. Now, this is something that's important to kind of notice that's going on in the background. Absolutists and monarchs are going to heavily invest in scientific discovery, right? They invest in it much like patrons did in artwork, right? These monarchs of many nations will actually patron scientists to continue to study, and Tycho is a great example of that patronage, right? Now, the thing about it, though, is while living on this island that he had not one, but two very large houses on, he spent years analyzing the stars, and he is one of the main, or probably one of the most important naked eye astronomers, is what he's referred to as, right? So, the thing about it, though, is he spends years analyzing the stars, trying to come to a conclusion of the setup of the universe. Now, the thing about his setup of the universe is he actually held true to the church model, and he still believed that the geocentric model was the way to go. And he believed that basically the Earth was here, the sun was there, and the sun was going around the Earth, but then all the other planets were going around the sun, but the Earth was stuck in the middle, right, and did not move and was motionless, right? So his idea and his model was wrong, right? But the thing that was most important about Tycho Brahe was the amount of data that he collected, right? So now Tycho, aside from being a guy that loved to rage and loved to hang out and loved to have his friends over and stuff like that, so much so that actually at one party that he lent out his like pet to, he had a pet moose that he lent to a friend that went to somebody's house, got drunk and fell down a flight of stairs and died. And then he also did all of this while wearing a prosthetic nose, because literally he like lost his nose in a duel with his cousin over a math problem, right? And so whenever he would drink a little too much, he'd sweat and it would like fall off his nose and into his plate, and it's very, very funny. But also he had like a person, like a little person that lived with him and stuff like that he would like take out at parties, and he said he was clairvoyant. His name was Jep. So like now that was like a whole like an era of weird guy thing. But here's the thing though, regardless of all his shenanigans, that obsession with studying the stars is going to result in a huge set of data that later astronomers can use. And that set of data was referred to as the Rudolphine tables, right? The reason why I have 777 on there is due to the fact that Tycho is going to study the movement and location throughout the year and throughout the night of 777 different celestial bodies and stars, right? And in this process, okay, of documenting all of this, because it's something you have to understand about science, is a lot of it hinges on data. It needs data to actually keep going forward and keep proving new theories, right? So the Rudolphine tables with this massive set of data, and he's also going to observe a very interesting thing. A supernova, right? In the constellation of Cassiopeia, he observes a star being born, right? And with this, he realizes, right? Wait a minute. This disproves Aristotle and Ptolemy's idea that the perfect matter that exists within space. It's actually not true. It's actually very chaotic. It's blowing up. It's exploding. Things are being born. Things are dying, right? And so with this data set and this new discovery of the supernova, it's going to break some of the old, like antiquated models of the universe and how it works, right? His conclusion, like we said, was wrong, but his data set was very important. Now, his assistant is also very important. His name is Johannes Kepler, who is the German assistant to Tycho Brahe. Now, for those of you who are also doing a lot of extra digging and you're like looking around online, you're like, well, Mr. Terry, what's the deal with the fact that Rudolphine tables are named after Rudolph I, the Holy Roman Emperor, if he was a Danish scientist, right, living in Denmark? Well, the reason why is because the king actually had died, the one that gave him that island and all that stuff, right? And the son that took over for that Danish king decided to kick Tycho Brahe out. He was like, I'm tired of paying for this shenanigans, right? And Tycho Brahe then moved to the Holy Roman Empire, where the King Rudolph actually, or the Holy Roman Emperor Rudolph, funded a lot more of his research there. And that's why he dedicated those tables to him, right? So now the thing about it is, while he was doing that work, his German assistant, Johannes Kepler, is going to be a very important figure. Now, after Tycho Brahe dies, though, Kepler is going to begin a lot of very important work. And he's going to use that data set left behind by Tycho Brahe to use also complex mathematics, Archimedes-style mathematics, to prove heliocentrism is real with math, right? Now, like, this is a big deal, right? We're going to prove it with math, right? Because heliocentrism and the movement of the planets will be set up by 3 Kepler laws, right? Kepler will use complex mathematics to realize that the planets do 3 things like clockwork all the time, right? And in this, he realizes that law number 1, heliocentrism works if you make the orbits ovals, not circles, right? So he realizes very quickly that retrograde motion, the reason why we see it and perceive it is because we believe the orbits to be circular, right? And if they're circular, it means that we're moving at a certain distinct pattern. And he said, no, it's actually they're oval and elliptical in shape, which efficiently solves the retrograde motion issue when you couple it together with his other 2 laws. Number 2, planetary speed changes upon distance from the sun, right? Basically, he's saying that as the Earth gets closer to the sun earlier or later in the year, it speeds up, right? Interesting little fact. During the wintertime, we are actually closer to the sun than we are during the summer. I know some of you are like, but why is it so cold then? We'll talk about that in class, all right? So the thing about it, though, is that he realizes that as the tracks of the actual orbit are shorter or depending on their distance from the sun, they speed up. His 3rd law is he realizes that the time of orbit is relative to the distance to the sun. So the closer your planet is to the sun, the faster your year is, right? For example, Mars, their year lasts longer than ours. I don't know why I said they, as if people are living out there, but the year of Mars is longer than ours. It's Mercury's is very, very short, hence why it's called Mercury, because it goes around the sun so fast, right? Because it was named after the Roman equivalent of Hermes, all right? So the thing about it, though, is when you take his 1st law and couple it together with the other 2, his biggest thing is he uses mathematics to prove Heliocentrism is real, and he fixes the retrograde problem, right? Because he's like, look, because if we're here and moving faster than Mars, that's why it looks like it's moving backwards when it actually isn't. Isn't that right, sweetheart?
I mean, can I ask you a question?
Yeah, sure, you can ask me a question.
What do you mean he uses math? Like the circumferences and diameters and distances. And
Yes, the
timing.
circumferences and diameters and distances from the sun, given the time of the orbits and on their path, and he uses that complex mathematic to realize that the law of planetary motion and speed actually is equivalent, and the planets are literally covering the same amount of distance or lesser distance depending on their location.
Sure, I get all that, but that had to have taken like 20 years.
Oh yeah, it took him a long time, like a long
That's
long
like
long
the
time.
longest math problem.
Yeah,
anyone
ever.
could
Yeah,
do.
exactly. And
So
he
these
used
guys are
used a
like-
fun little things called trigonometry, y'all. Fun fact. Yeah, trigonometry is important. What?
That just seems like I don't have the patience for that.
Oh, we know you don't have the patience for that. So like, it's okay, but I love you regardless. Now, anyway, last but not least, now we got to talk about a very, very important scientist that's super, super stupid important. His name is Galileo Galilei, right? Probably the most important guy that we've talked about so far. He is an Italian scientist that is going to prove the heliocentric design, not with math this time, because still experts and church authorities rejected Kepler's stuff because it used math. Galileo is going to prove it with observation, using your eyeball so you can see it, right? He is an Italian scientist that will prove the heliocentric design. How does he do this? He uses his telescope. Now, a really, really quick little fact that you probably need to know for the rest of your life. He did not invent the telescope. He did not invent it, all right? He actually is just going to perfect it, all right? For his patrons that paid him a lot of money for a lot of his research and stuff like that, he would oftentimes make them little trinkets or tools or scientific devices as gifts to be like, hey, look what your money's paying for, right? And so one of the things that, for example, he did make for a Venetian patron is a telescope so he could see ships coming in from the harbor from a further distance. Well, if you can see ships going over water from really far away with a telescope, what happens if you point it towards the sky? And so he starts looking at the sky with it at night, right? And he observes comets, the moon, the moons of Jupiter. He realizes that other planets have moons, right? That we're not alone in the fact of having a moon. And he also discovers and like observes other moving bodies. Now, in this, he realizes that size has a very great relation between heavenly bodies and their path on movement. Because he realized that our moon is a pockmark of a bunch of craters and stuff like that, meaning that nothing out there is perfect because comets have been crashing into it this whole time. And he also realizes that the moon is smaller than Earth and it's caught in our orbit. He also realizes that Jupiter has tons of moons that are much smaller than it is, and actually are even larger than the Earth, that are going around Jupiter because Jupiter is so large, right? And so he realizes that size in relation to heavenly bodily items is very important. And he knows that the sun is far larger than any planet that exists nearby it. And so he's like, wait a minute, we must be going around it, right? And he's using observation to do this. Now, the thing about it is when he discovers this, he wants to share his ideas with the church, right? He goes up to his buddy Urban VIII. That's right, Urban VIII is the Pope and Galileo knows him. They have met each other like 6 times in real life, right? Urban VIII is a funny, quirky little character that we'll talk about in class a little bit more later on. But the thing that's really, really interesting is that when he comes up with all of this stuff, all right, he wants to write a book. And he goes to Urban, he's like, hey, Urban, big fella, buddy, can I write a book publishing my findings showing that the heliocentric model is actually the real one? And Urban looks at him and goes, oh, God, this again. All right, like, okay, look, Galileo, look, big guy. We know. We're aware. And Galileo is shocked. He's like, what do you mean you know that the earth goes around the sun? He's like, we've known for a long time. Like, he's like, the church has been very well aware. But you got to remember something. We're in the middle of a Reformation, man. We're losing a lot of Protestant followers. We've been saying the earth's in the middle for a really long time, and for us to go back on it, it's going to make us look bad, right? And also, if you look at the year that the book that he writes was published, it was published in 1632, during the 30 Years' War, right? So the thing about it is that Urban tells him, he's like, okay, Galileo, you can write your book, but I need you to do me a favor. You need to present both sides, right? You need to present the heliocentric model and the geocentric model in equal validity. And Galileo goes, sure, I'll do that, with his fingers crossed behind his back, because he doesn't. He writes the book, and he has 2 different characters in it. Well, actually, there's 3 characters. In his book, known as The Dialogue of the 2 Chief World Systems, that you can see the cover piece right here, there are 3 different characters, right? There's one impartial person and 2 people trying to convince him, right? And the 2 people trying to convince him, one represents the heliocentric model, and the other one represents the geocentric model and the church. And the one that represents the geocentric model and the church is known as Simplicio, which means idiot. So yeah, and he actually really made the church look bad, right? And this is going to land him in a lot of hot water, and it's going to end up getting him put in front of an inquisition, right? He is tried in front of an inquisition for heresy due to his publications, but the fact of the matter is that he used his eyeballs to observe the fact that the earth goes around the sun. So Galileo is the one that proves it beyond a shadow of a doubt. Regardless of this inquisition trial, regardless of being called a heretic, regardless of Urban being like, dude, why'd you do that? And also blowing up in the church's face, he still proved it, right? And the thing about it, though, is that he was forced to recant his ideas. They told him you can either burn at the stake or take it back and spend the rest of your life under house arrest. And so he picked take it back and spend the rest of my life under house arrest. And so regardless of that fact, though, he is going to prove this stuff beyond a shadow of a doubt, right? And this is very, very important. And he also proves some other things while he's under house arrest, right? While he's under house arrest, he actually proves that items, when dropped, fall at the same speed to the earth, right? He also proves that all moving objects through the air move on a parabola, and uses mathematics to basically postulate the idea that you could one day make satellites, right? So Galileo was a phenomenal figure. And it's funny because he died under house arrest, and we have a couple of remaining little artifacts from him, right? And my favorite little fact about Galileo is the guy that was told to take it back, told to say he was wrong, told to admit that his discoveries were false, is just laughingly from the grave, just giving everyone the middle finger, because literally his middle finger is in a glass jar in Florence, right? It's in this glass jar in Florence because somebody stole it from his grave and then sold it to a couple of different people, but it now is in a museum in Florence where it sits in a glass jar, just sticking up directly at the world, being like, I told you I was right, all right? So now going into it, though, we're going to cut it off right there. Speaking of cut it off, middle finger, get it? So but we'll cut it off right there, and we'll talk about some more of this stuff in class, but I'll see y'all soon. Y'all have a good one.